Okay, last time we learned about a couple polynomial theorems. We had the remainder theorem, the factor theorem, and the complex pair theorem. So today, this quiz is about two other theorems, the rational zero theorem, sometimes called the rational root theorem, and Descartes' rule of signs. So let's look at the first theorem, rational zero theorem. The rational zero theorem says if you take all the factors of the last term and divide them by all the factors of the first term, you have your list of possible factors that go into your polynomial. So let's say we have this polynomial. Let's say we have 2x to the fourth plus x cubed minus 17x squared minus 16x plus 12 equals 0. We would take the factors of the 12. All of the factors of 12 are plus or minus 1. We have plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. My pen is not working that great today, sorry. Then we take the factors of the first term. We have 2. You don't need to include plus or minus on the factors of the first term because then they start repeating themselves with the first term. So you can just write the factors of 2, which are 1 and 2. Now to find all of the possible roots, what you need to do is divide the factors of the last term, so we've got, and divide them by each of the factors of the first term. So you take 1, 2, 3, 4, 6, and 12, divided by 1, 1, 2, 3, 6, 4, 6, 12, and divide by 2. So all the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are each divided by 1. And then we're going to go plus or minus 1 divided by 2. Plus or minus 2 divided by 2 is just 1, so I don't need to rewrite that. We have plus or minus 3 divided by 2. Plus or minus 4 divided by 2, plus or minus 6 divided by 2, and plus or minus 12 divided by 2 are all in our original list. Because 4 divided by 2 is 2, I have that. 6 divided by 2 is 3, we have that. 12 divided by 2 is 6, and we already have that. So then this list right here represents all of the possible factors or zeros of our polynomial. What that means is you can test these ones into synthetic division in our polynomial, and then that's it. You don't have to test any number outside of these numbers. If none of those works, then that means you have no rational zeros of your polynomial. The next theorem we're going to take a look at is Descartes' rule of signs. So let's bring that up. Okay, so now we have our list of possible rational roots. Now we can figure out how many of those would be positive and how many of them would be negative. So to find that out, we use Descartes' rule of signs. Descartes' rule of signs just says to find the number of possible positive roots, we count the number of sign changes. So we have one sign change because we're going from positive to negative, none, and then we have 2. So we have 2 sign changes. So that means that you can either have 2 or 0 possible positive roots. Now you're probably thinking, wait, why 0? Where'd that come from? So what you have here is you could have 2 positive roots, or you could have 0 positive roots and 2 imaginary roots. So whenever you're finding Descartes' rule of signs, the number of positive or negative roots, you take the number of sign changes it has and keep going down and subtracting an imaginary pair until you get to 0. So if we wanted to find the number of negative roots, All you need to do now is say, well, the total roots here, how many total roots do we have? It is 4, because that's the highest power. So the negative roots, you look at the highest amount of positive roots, which is 2, and you have 4 total. So how many are left over? 2. So that means you can have 2 positive roots, or you can take an imaginary pair out, and then you could have 0. So the chart on that would look like this. So you have, for the positive, you can have 2 or 0 positive. For negative, you could have 2 or 0. So this could have 2, or this could have 0. This one can have 2 or 0. Now what that means is you will have non-real roots. Here, 2 plus 2 would be 0 non-real. 2 plus 0 would be 2 non-real. 0 plus 2 would be 2 non-real. 0 plus 0 means you would have 4 non-real. And if you find the total of that, every time you should add up to 4 roots.